1,200,000,000 fashion items are produced annually from wool. Why does this fiber remain dominant after centuries? It seems easily replaceable, but its structure ensures its place in the industry, revealing that behind every heavy coat lies a process as intricate as it is precise. But this is just the beginning. Shearing initiates the transformation on wind-swept pastures. One can notice how the raw material is washed and carded to align the fibers. The equipment gradually removes impurities to reveal the clean texture. The fleece moves forward for the next step. At first glance, the fiber seems simple, but in reality, a complex chain of transformation operates beneath the surface. Factories run day and night to spin the wool and weave it into fabric. It is visible how craftsmanship merges with technology to refine the raw gift of nature. The process is only gaining momentum. Consequently, the ordinary fleece becomes a pillar of the global fashion industry. The wool has turned into a finished material. The textile moves to the next phase without haste. Over 4.4 billion pounds of wool are harvested annually from pastures. Australia, China, and New Zealand lead the field. One can notice how these three nations supply more than 60% of the world's total output. It seems like a simple trade, but in reality, it remains a cornerstone after centuries of existence. Why does the economic value exceed $80 billion annually? The figure includes both raw fiber exports and finished textile products. This valuation underscores the global importance of the industry. From sprawling farms covering thousands of acres, the raw material enters production lines. The camera glides along conveyors as fiber becomes everything from sweaters to upholstery and high-performance insulation. But this is just the beginning. China stands as the largest processor and consumer. Conversely, Australia leads in the production of fine, high-quality wool. It is visible how the fiber acts as a link between nature and technology. Wool represents one of the most renewable natural fibers. The material acts as a pillar of sustainable fashion, continuing a story thousands of years in the making. Two major regions, New Zealand and Australia, serve as the global epicenter for this initial stage of wool production. Why do farmers adhere to such rigid management standards for every flock? The answer lies in the delicate nature of the fiber itself. Strict protocols are required because only controlled environments ensure the fleece remains the cleanest and most consistent raw material on the market. Selection of specific breeds defines the entire production strategy. Farmers choose merino for ultra-fine fibers, while Romney or Corriedale provide longer, stronger strands that are easier to weave. One can notice how the flocks graze rotationally across the vast open pastures. This technique keeps the soil fertile and prevents overgrazing, ensuring the land supports the animals year-round. Every sheep is tagged and recorded with precise details about its age, health history, and total fleece yield. Their diet is carefully supplemented with hay, grains, and minerals to promote thick, uniform, and bright wool growth. Barns remain dry and well ventilated to prevent parasites and skin diseases. But this is just the beginning of the care regimen. Each season, farmers vaccinate, deworm, and inspect every animal. The sheep's physical health directly determines the fiber's final quality. Before breeding season, ewes undergo a process known as flushing. At first glance, feeding seems routine, but during this period, the diet is enriched for several weeks to boost fertility. This results in stronger lambs with finer wool, capable of nursing promptly under close supervision. After a few weeks, the young are tagged, weighed, and moved to lush pastures for weaning. It gets more complex further on. When the warmer months arrive, the flocks are washed and treated for ticks. It is visible how the animals are left to dry naturally before the shearing begins. Each sheep is handled gently to avoid stress, ensuring the removal of a single, clean, unbroken fleece. One can observe how the animals are checked again and treated for minor cuts immediately after the process. Allowed to rest, the flock returns to the fields to regrow their coats. Every stage, from nutrition to shearing, follows strict animal welfare standards to guarantee value. Thus, the raw material reaches the purity and durability required for the next phase. 250 sheep per day. That is the heavy workload and experience professional handles during the shearing season to harvest fleece of the highest value. Why does the process begin only when the weather starts to warm? It might seem like a simple logistical choice. This timing ensures the sheep stay comfortable after shearing and have enough time for their wool to fully regrow before winter. Before the work starts, the flock is kept in clean, dry pens and fed lighter portions to keep them calm. But this is just the beginning. The shearers use precision electric clippers with fine blades to navigate the animal's body. They move in a specific sequence, starting from the belly and legs, then continuing to the sides, shoulders, and back. One can notice how the goal is to remove the entire fleece in one smooth, continuous motion without breaking the fibers. An average session takes just 1 to 2 minutes per animal. The blades glide over the skin, harvesting the result of a year's growth rapidly. At first glance, the shorn fleece looks like a single mass, but in reality, short, dirty wool from the belly and legs is immediately separated for lower-grade products. The long, fine white fibers from the back are strictly reserved for high-end textile manufacturing. Staff check the sheep for cuts, treat them with antiseptic, and allow them to rest in wind-sheltered enclosures. It gets more complex further on. From the shearing sheds, the raw material moves directly to the sorting area tables. Because even with modern automation, human craftsmanship remains essential for quality control. Skilled graders examine each fleece for color, fiber length, and fineness, removing sections tangled with grass or dirt. It is visible how they separate the material by region to ensure consistency across production lots. Transition to the next level. Powerful hydraulic presses compress the clean batches into dense rectangular bales, weighing between 300 and 400 pounds. The machine exerts immense force to compact the fibers. They are tightly wrapped in burlap or heavy plastic to protect the contents from moisture. Detailed tags record the farm of origin, sheep breed, and wool grade to ensure full traceability. And this is not the limit. Specialized trucks carefully load the massive white bales for transport to the processing facility. Therefore, the material arrives at scouring plants where the industrial journey truly begins. The wool undergoes washing, degreasing, and purification to remove impurities. It is now ready to become the foundation for fine textiles. 180 degrees Fahrenheit is the precise thermal threshold required to strip raw wool of its natural oils. But before reaching this heat, the material undergoes a brutal mechanical awakening inside the opener. Why subject soft fleece to high-speed rotating metal teeth immediately after unpacking? It would seem safer to wash it gently first. However, without this aggressive separation, water would never penetrate the dense clumps to clean them effectively. Rows of steel spikes tear through the fibers, shaking loose embedded dust, grass, and soil. The wool is now loose, but this is just the beginning of its purification. The scouring system submerges the material into 6 continuous tanks. The first 3 hold a diluted soap solution to target lanolin, the grease protecting the animal's fleece from moisture. One can notice how soft press rollers between each tank gently squeeze the fibers, forcing out dirty water in dark streams without damaging the strands. At first glance, this massive water consumption seems wasteful, but in reality, automated pumps recirculate liquid in reverse flow to conserve energy. Sensors strictly maintain the heat between 170 and 180 degrees Fahrenheit. The dissolved lanolin is collected and refined separately for cosmetics. It gets more complex further on. Clean water in the final tanks rinses away the last traces of soap. One can observe the wet wool entering rotary drum dryers where warm air penetrates every strand. The drums rotate continuously, tumbling the material to ensure even evaporation. When the fibers emerge, they possess a standard moisture level of about 12%, appearing soft and bright. Because uniformity is paramount, the dried bales move to the fiber blending machine. Rollers with spiral blades mix batches differing in color or fineness, separating clumps. A fine mist system keeps the air humid to prevent static electricity, while sensors monitor the speed. The fibers emerge light and elastic. And this is not the limit. Structural formation awaits the chaotic mass of wool in the next mechanical phase. Multiple metal tooth rollers spinning at different speeds form the core of the carding machine. They force the material through, creating controlled friction that straightens tangled fibers into a single uniform direction. Dust extraction systems remove short fibers and fine particles. One can see the material exit as a thin, continuous web that is automatically rolled into soft slivers. In artisan studios, this mechanical process is replaced by the ancient art of hand carding. Masters use two brush-like paddles covered in fine steel teeth, interlocking and pulling them apart repeatedly. This motion is performed dozens of times until every fiber lies perfectly parallel. The result preserves the wool's natural elasticity and sheen, readying the fiber for its final application. Multiple rollers rotating at distinct speeds receive the refined wool slivers once the combing stage is completed. This creates a quality and texture in ways that machines can hardly replicate. The material transfers to the spinning section, the critical phase that determines the strength and fineness of the fiber. At first glance, the multi-roller spinning frame seems to move uniformly, but in reality, the rear rollers accelerate slightly while the front ones hold the fiber steady. This difference applies a gradual drafting tension, drawing the sliver thinner while maintaining its elasticity and internal cohesion. But this is just the beginning. Why is the surface of each strand coated with an ultra-thin layer of spinning oil before the twisting unit? The friction during the drafting process is intense. This lubricant is necessary to prevent static buildup caused by continuous movement. One can notice how the central twisting assembly tightly binds the fibers into a unified strand. This forms a structure that is both strong and resilient. The degree of twist is monitored by tension sensors, ensuring perfect consistency along the entire length of the yarn. Finished yarns are wound onto large bobbins and later rewound into smaller spools of standardized size. The process is only gaining momentum. Optical scanners inspect each strand in real time, detecting thick spots, weak points, or over-twisted sections. Any flaws are automatically trimmed and rejoined using heat fusion. It is visible how the system produces smooth, seamless joints, nearly invisible to the naked eye. In smaller workshops, traditional artisans still preserve the heritage of hand spinning with a spinning wheel. They rely on tactile control to adjust the twist intuitively. This slow and deliberate method yields yarns with a distinct organic character, often reserved for high-end handcrafted woolen products. The final yarn emerges with exceptional tensile strength, smooth texture, elasticity, and structural integrity, representing the result of precise engineering combined with generations of craftsmanship. Thousands of strands are threaded through needles and heddles to form the structural foundation of the fabric on the loom. Why is such extreme precision required during this initial warping stage? It would seem sufficient to simply load the material for weaving and let the machine run. However, each strand must align perfectly because even the slightest deviation can irrevocably disrupt the intended pattern of the final textile. Before the mechanical rhythm even begins, automated sensors measure the tension, humidity, and density of the yarns to ensure stable operation. But this is just the beginning. The material transforms from loose threads into a unified textile structure only after these parameters are confirmed. One can notice how the weft threads are interlaced mechanically by a shuttle or air jet system. Immediately after, the reed compacts them firmly, locking every fiber tightly with the warp. It gets more complex further on. At first glance, the loom operates at a speed that seems chaotic, but in reality, every movement is monitored by fault detection sensors. If a broken yarn, loose tension, or sequence error occurs, the machine halts instantly. This pause allows operators to correct the issue manually before production resumes. It is visible how the fabric accumulates as it reaches its standard length and is wound onto a take-up beam. The process is only gaining momentum. Therefore, the roll moves immediately to the inspection area under bright lamps. Minor flaws, such as knots, dark specks, or uneven tension, are corrected by hand under the intense light. Thus, the woven wool fabric achieves a solid structure and uniform surface, serving as the essential foundation for the finishing treatments that will follow in the mill. Hundreds of meters of raw wool fabric arrive at the finishing department for structural stabilization and texture refinement. Why immerse the textile in warm water with gentle agitation? It might look like a standard cleaning procedure, but this specific environment allows the wool fibers to interlock naturally, significantly increasing the material's density. This controlled friction enhances thermal insulation properties while thickening the cloth. But this is just the beginning. One can notice how the fabric passes through fine carding rollers equipped with delicate metal pins. These mechanisms smooth the surface texture and remove any loose fibers that disrupt uniformity. Certain batches undergo dyeing according to strict design specifications. The process is only gaining momentum. Because stability is crucial, steaming sets both the color saturation and the physical dimensions of the cloth. Afterward, the fabric is dried at a controlled low temperature to preserve the material's softness, elasticity, and natural luster. By the end of this sequence, the rough textile transforms into a smooth, resilient material suitable for tailored coats or luxurious blankets. Transition to the next level. Consequently, finished wool fabrics move to the cutting and sewing section to take their final product shape. Inside the climate-controlled room, the fabric stabilizes for specific temperature and humidity levels. At first glance, the material seems ready for immediate cutting, but in reality, without this stabilization, precision would be compromised. Automated rotary blades glide along digital templates to ensure perfectly smooth, accurate edges. It is visible how each piece is numbered before being transferred to sewing stations. Double needle machines assemble collars, hems, and sleeves under the pressure of steady steam presses to preserve the shape. It does not end at this stage. Once inspected, every garment undergoes final steaming and folding. Workers seal and label the products for global distribution, completing the wool's journey from open fields to the modern wardrobe. The finished product awaits shipment without haste. Thousands of kilometers separate the vast open grazing lands from the high-tech mill floors. Why is such strict precision required for simple wool? At first glance, the raw material looks robust enough to work with immediately. However, only technology can refine the fiber for complex industrial use. The journey demonstrates a balance between nature and machines. One can notice how the chaotic fleece aligns into a perfectly orderly product. But this is just the beginning of the cycle. Human ingenuity drives this craftsmanship to new levels of quality. Every step transforms the fiber further. Thus, the material is ready for its final application.